Hi students, welcome to the session on dielectric constant. In this class we learn about a dielectric constant and its significance and terms related to that. Right? We know that when we keep our dielectric, let us assume this is our dielectric, in external electric field like this, what happens? The charges aligned along the direction of dielectric, right? That we studied in dielectric. They change alignment like this, and it undergoes polarization. So hence, what happens? There will be a internal electric field induced. This electric field opposes the external electric field. So what is the total electric field in dielectric is given by E total is equal to E external plus E internal. Okay, and internal electric field is opposing the external electric field. So it is E internal is opposite direction of E external, and magnitude of E internal is less than E external, right? It won't be equal like what we saw in our conductor. So what happens? E total is always less than E external, because E external minus E internal. So total electric field experienced by dielectric is lesser than external electric field. This concept we know. Now we define one new term called dielectric constant, which is given by E vector, that is E total is equal to E external divided by kappa. This kappa K is pronounced as kappa, which is known as dielectric constant. Okay, and we know that E total is less than E external. Fine. So this implies kappa is equal to E external minus E, so which is always greater than 1, because E total is lesser than E external, right? This is the way we can define dielectric constant. So dielectric constant kappa is also known as relative permittivity. What is relative permittivity means, right? It is simply epsilon r. It is given by, which is equal to permittivity of a substance, to the permittivity of a free space. It is a ratio of permittivity of a substance to the permittivity of a free space, right? So this is generally a mathematical form. Logically, what is the meaning it is? So dielectric constant is simply a ability of a substance to store electrical energy in electric field, right? That's what our K implies, right? So it is simply ability of a substance, right, to store energy, electrical energy in electric field. See, the same thing we can express like this also, relative permittivity. What is permittivity? First we must know. What is permittivity of the medium? Permittivity is just, it is a measure of resistance, right? It is a measure of resistance encountered, right? So while it is encountered in a medium or substance, okay, when forming an electric field inside it, electric field, that is, it is a resistance to the electric field, simply, or to electric field by a medium, right? Resistance given by a medium to form an electric field, right? So that is what permittivity of a substance we can call, that is epsilon, right? So epsilon r, that is relative permittivity, that is epsilon. Epsilon means the permittivity of the medium with respect to permittivity of a free space, that is known as epsilon naught. So it is a ratio of two numbers. that you can equate to kappa, right, or dielectric constant. Both are having the same meaning. Under rare conditions, the meaning will be different. Otherwise, you can call dielectric constant as a relative permittivity. So, dielectric constant is also, we know that it is what do you call? It's the ability of a substance to store electrical energy in electric field. Whereas, what do you call this? Relative permittivity is the this is permittivity of the medium with respect to permittivity of the what do you call free space, right? So it is comparing the permittivity of the medium with respect to free space. Let us consider this is acting as a reference. That's why it is now called relative permittivity. Comparative permittivity of this medium compared to this reference. That's why it is known as relative permittivity, right? And next parameter we have to know is dielectric breakdown, right? So we know that in dielectric atoms are tightly bound, right? So in atoms, what do you call? In atoms, all the charges are tightly bound, right? In atoms, all the charges are tightly bound in dielectric, right? So if you apply electric field, what happens in conductor? The electrons becomes free electrons and it starts conducting. Whereas since atoms are in atoms charges are tightly bound in dielectric, when you apply electric field, they won't become free electrons. Electron won't get detached from the atoms, right? So it won't happen simply. But when you increase the electric field to very large amount, electron gets detached from atom. It requires very large amount of electric field, right? Detached from atom and start becoming free electrons. So once it is becoming free electrons, it will become a conductor. So when you apply very large electric field like this, dielectric behaves like a conductor, right? So this phenomena is known as dielectric breakdown. Okay, this is what we call as dielectric breakdown, right? We know that if you increase electric field, the electrons won't get detached simply, right? We have to increase. At one point of electric field, uh, the dielectric becomes conductor, right? So the maximum electric field, the dielectric can withstand before it breaks down. Before it breaks down is known as dielectric strength, right? Dielectric strength. Okay, so this is what we know dielectric strength. So that it's a maximum electric field. Dielectric strength is nothing but maximum electric field your dielectric can withstand. For air, dielectric strength is 3 into 10 power 6 volt per meter. Right? That means what? It is 30 lakhs volt per meter. Up to that much value or electric field, our air can withstand. Once it is dielectric, once it is greater than 3 into 10 power 6 volt per meter, then only we will see some spark like lightning, right, or thunder, like okay. So what happens here is the unit is volt per meter for dielectric strength because it is nothing but a maximum electric field. Whereas for dielectric constant we know it is given by epsilon by epsilon naught, or we can say Ek is equal to E external by E total, right? Both are, you see, this is a ratio of two same quantities, permittivity of a substance to the permittivity of the medium, or external electric field to the total electric field. Since both are same quantities, the unit will be cancelled. So kappa or dielectric constant is unitless, whereas the dielectric strength as a unit of volt per meter. Right? So that's all about this session. I hope you understand everything clearly. If you have any doubt, please ask me in comment section. Thank you.